Students, so welcome back to my video lectures on the fourth chapter. Okay, what is it? Chemical bonding and molecular structure. So what we were doing, students, we were solving we were solving the multiple choice questions. Okay, so we are covering the various questions from various textbooks, and also we were also solving MCQs from the previous year question papers of your NEET, IIT JEE as well as Karnataka CET. Okay, I'm going to cover all the three. We will solve all the previous year question papers of NEET, IIT JEE as well as Karnataka CET, and also I'm going to cover most of the MCQs from all other textbooks. Okay, yes. So students, how many questions we have solved? I think we have solved up to 34 questions, isn't it? Yes. Okay, I think we have solved up to, this was the last question, 34. And what is the correct answer for this? The correct answer for this was, it is option D. Okay, more the bond order, lesser will be the bond length. Okay, so answer D, I have given it. Hope you're watching my previous videos also. Yes. Okay, yeah, I'll go with the next question, students. Okay, using MOT, compare O2 plus and O2 minus species and choose the incorrect option. Okay, using MOT, compare O2 plus and O2 minus species and choose the incorrect option. Choose the incorrect option. So look here, I have taken this from Karnataka CET 2015. Okay, so that means we are solving problems previous year question papers also. Okay, yes, O2 plus and O2 minus. Actually, again there is a printing error. It is supposed to be O2 plus and O2 minus. O2 plus and O2 minus. Okay, so question clearly says using MOT, MOT means molecular orbital theory. Using MOT, we have to compare O2 plus and O2 minus species and choose the incorrect option. O2 plus and O2 minus. So for MOT, we have to write the electronic configuration, isn't it? We have to write the electronic configuration. Well, we know oxygen has O2 plus or O2 minus has more than 14 electrons. So more than 14 electrons means the second electronic configuration, as I have stated earlier. Okay, yes. What is the electronic configuration that you're going to use for the species with more than 14 electrons? Yes. Okay, electronic configuration is going to be sigma 1s, sigma star 1s, sigma 2s, okay, sigma star 2s, then sigma 2pz, okay, more than 14 electrons, yeah, sigma 2pz, then pi 2px, okay, pi 2py, okay, and then pi star 2px, okay, pi star 2py, and lastly sigma star 2pz, sigma star 2pz. Okay, yes. So students, okay, in all the options, here is talking about bond order, okay, diamagnetic, paramagnetic. Let us see all other aspects, every aspects of O2 plus and O2 minus. Okay, so let us do it for O2 plus. O2 plus means how many electrons? 8 plus 8, 16 electrons. There is one positive charge, means minus 1. So 16 minus 1 is 15. So let us fill the 15 electrons here. Okay, how do we fill? Okay, 2, 4, 6, 8, 10, 11, 12, okay, 12, 13, 14 and 15. Well, just look at the electronic configuration of O2 plus. O2 plus. Look at the electronic configuration of O2 plus. See, in the electronic configuration, there is one unpaired electron, isn't it? Okay, there is one unpaired electron. Okay, since there is one unpaired electron, Okay, we know if there is one unpaired electron, hence can I say that O2 plus is paramagnetic? Yes, O2 plus is paramagnetic. Excellent, because there is one unpaired electron. So if there are unpaired electrons, paramagnetics. If there are no unpaired electrons, means diamagnetic. Hope you are all able to understand. Okay, now let us calculate the bond order of O2 plus. So what is a bond order? Bond order is half of Nb minus Na, isn't it? Bond order is equal to half of Nb, number of bonding electrons, minus number of anti-bonding electrons. Okay, half of number of bonding electrons minus number of anti-bonding electrons. So how many number of bonding electrons? Yeah, just check. 2, 4, okay, 6, 8, 10. 10 minus anti-bonding electrons 2, 4, 5. So 10 minus 5 is 5. 5 by 2 is 2.5. So what is the bond order of O2 plus? It is 2.5. Hope you have all the informations now. Okay, O2 plus is paramagnetic in nature and its bond order is 2.5. On the same lines, let us take up the next species. What is it? O2 minus. Okay, yes. Just check the number of electrons here. 8 plus 8 is 16. 16 plus 1 is 17. So if, okay, I hope you are able to understand. Okay, if there is positive charge, okay, you have to subtract that positive charge with the total number of electrons. If there is negative charge, you have to you have to add that negative charge with the total number of electrons. So the total number of electrons is 17 now. 17. Now let us write the electronic configuration of O2 minus. Okay, is that O2 minus? Yeah. Let us write the electronic configuration. Sigma 1s2. Okay, I'll write it here. Yeah. Sigma 1s2. Sigma star. Okay, 1s2. Okay, sigma 2s2. Sigma star 2s2, isn't it? 2, 4, 6, 8. Okay, and then yes, sigma 2pz2, yes, pi 2px, pi 2py, pi 2py. Okay, so how many? 2, 4, 6, 8, 10. Okay, 10. Yes, 11, 12, 13, 14. Okay, yes, 14. Pi star 2px, pi star 2py, 14. Okay, 15, 16, 17, and lastly sigma star 2pz. So total 17 electrons. Did we fill all the 17 electrons? Yes. Sigma 1s2, sigma star 1s2, sigma 2s, sigma star 2s2, okay, sigma 2pz2, sigma 2p, pi 2px2, pi 2py2, pi star 2px2, and pi star 2py1. We have filled in the increasing order of energy. That means we have followed Aufbau's principle and also Hund's rule of maximum multiplicity. Is that correct? Hund's rule of maximum multiplicity. So, okay, now just check. Okay, just check. Even in O2 minus, which is 17 electrons, isn't it? Okay, so O2 minus. So even there are there is one unpaired electrons in O2 minus. There is one unpaired electron in O2 minus. So again, there is one unpaired electron. There is one unpaired electron. One unpaired electron means this is also O2 minus is also what? Paramagnetic. Paramagnetic. This is also paramagnetic. Okay. Now what will be the bond order? Bond order is equal to half of number of bonding electrons 2, 4, 6, 8, 10. 10 minus 7. Okay. 10 minus 7 is 3. Okay. 3 by 2 is 1.5. 1.5. So we are getting the bond order to be 1.5. Look here, O2 plus is also paramagnetic, O2 minus is also paramagnetic. So we got the answer, students. Look here. Okay. So yes. Okay. Compare O2 plus and O2 minus and choose the incorrect option. You have to choose the incorrect option, students. Yes. Yeah. Okay. Yes. We have to choose the incorrect option. Okay, look here, O2 plus have higher bond order than O2 minus. Yes, the bond order of O2 plus is 2.5, whereas the bond order of O2 minus is 1.5. Yes, that means O2 plus has more bond order than O2 minus. Yes, so option A is correct then. O2 minus is less stable. Yeah, lesser the bond order, lesser is the stability. Yes, lesser the bond order, okay, lesser is the stability. Lesser is the stability. Stability. Understood? Okay, so the bond order of O2 minus is just 1.5. That means it is less stable than O2 plus. So option B is also correct. Option B is also correct. O2 plus is diamagnetic. No, O2 plus is paramagnetic, O2 minus is also paramagnetic. Therefore, the incorrect option is option C. Option C. Both O2 plus and O2 minus are paramagnetic. Yes, so this is also paramagnetic because this has one unpaired electron. This is also paramagnetic. Why? Because this also has one unpaired electron. Yes, that means this option is also correct. Therefore, the incorrect option is going to be option C. Option C. Any doubts with this? Is that simple? Okay, that's great. Okay, yes. Shall we go to the next question? Yes, students. Yes, let us pass on to the next question. What does the next question says? Okay. One of the following conversions results in the change of hybridization and geometry. Okay, I hope you are able to observe. We solved two questions from 2014 question paper, and we are also solving two questions from 2015 question paper. That means in your Karnataka CET, you can expect a minimum of two questions from this chapter. You can expect a minimum of how many questions? Two questions from this fourth chapter, that is chemical bonding and molecular structure. Molecular structure. Now let us go to the next question. One of the following conversion results in the change of hybridization and geometry. Okay, yes, one of the following conversion results in the change of hybridization and geometry. Okay, so that means if I convert methane to ethane, is it ethane? Yes or no? I am converting. Okay, there are many reactions wherein I can convert methane to ethane. For example, Woods reaction. Woods reaction is the simplest reaction wherein I can convert methane to ethane, isn't it? So if I convert methane to ethane, what will be the hybridization of carbon here and carbon here? Okay, so here methane CH4, CH4, yes, ethane C2H6, CH3, yes, CH3, okay, yes. So here the carbon is surrounded only by single bond. I have told you, if the carbon is surrounded only by single bond, then it is sp3 hybridization. If the carbon is surrounded by one double bond, sp2 hybridization. If the carbon is surrounded by two double bond or one triple bond, then it is sp hybridization. sp hybridization, didn't we? So here the carbon is surrounded only by single bond, means sp3 hybridization. Here also carbon is surrounded only by single bond, that means it is also sp3 hybridization. So if I convert methane to ethane, is there any change in hybridization? No, there is no change in hybridization. The question is, one of the following conversion results in the change of hybridization and there is a change in geometry. That is what the question is. Okay, one of the following conversion results in the change of hybridization and the change of geometry. Geometry means, is it regular geometry or irregular geometry? Okay, yes. Now let us go with the next one. What if I convert ammonia to NH4 plus? Ammonia to NH4 plus. If I convert ammonia to NH4 plus, ammonia, okay, we know NH3 is what? Okay, this is irregular geometry. This is irregular geometry, whereas this is regular geometry. Regular geometry. Is it correct? Because here, okay, nitrogen is surrounded only by bond pair of electrons. Here nitrogen is surrounded by both bond pairs as well as lone pair of electrons. Okay, now students, let us calculate the hybridization. Hybridization is equal to, what is the formula for hybridization? Half of, again I'll write the formula for hybridization. Hybridization is equal to half of V plus M, okay, minus C plus A. Half of V plus M minus C plus A. Okay, V means, okay, the total number of valence electrons around the central atom. M means the number of monovalent atoms. C means total positive charge. A means total negative charge. Total negative charge. Okay, so if, okay, the value comes out to be equal to 2, what is the hybridization? SP. For 3, yes, SP2. Okay, for 4, SP3. Yes, 5, SP3D. 6, okay, SP3D2. And 7, SP3D3. SP3D3. Okay, 7 means SP3D3 hybridization. So let us calculate the hybridization of this nitrogen and this nitrogen. Anyhow, they don't have the same geometry. One is regular geometry and the other one is irregular geometry, isn't it? Okay, now let us calculate the hybridization, by the way, half of. Okay, so nitrogen 15th group. 15th group means how many valence electrons? 15th group means how many valence electrons? 5 valence electrons. Okay, total, okay, then number of monovalent atoms 3. Okay, total positive charge 0, total negative charge is also 0. So 5 plus 3 is 8, half of 8 is 4. So if you take H is equal to 4, what is the hybridization? If H is equal to 4, the hybridization is going to be sp3. The hybridization is going to be sp3. Okay, is that correct? Yes. Next, if I go, okay, with this one, hydrogen is equal to, state of hybridization is equal to half of, okay, number of valence electrons. Nitrogen belongs to 15th group. 15th group means 5 valence electrons. Number of monovalent atoms is 4 minus total positive charge is 1. Okay, so 5 plus 4 is 9. 9 minus 1 is 8. Half of 8 is 4. So hydrogen, okay, state of hybridization is 4. Again, it means sp3 hybridization. sp3 hybridization. Is that correct, students? Yes or no? Yeah. Okay, it is correct. Okay, that's great. Okay, so there is only change in geometry, but there is no change in hybridization. Okay, but the question is, one of the following conversion results in the change of hybridization as well as geometry. Now if I go for BF3 to BF4 minus, BF3 to BF4 minus, BF4 minus. Okay, come on, let us calculate the hybridization for BF3. H is equal to half of, boron belongs to 13th group. So total number of valence electrons is 3. Total number of valence electrons is 3. Okay, number of monovalent atoms is 3. Total positive charge is 0. Total negative charge is also 0. So 3 plus 3 is 6. Half of 6 is, okay, 3. 3 means what type of hybridization? sp2 hybridization. Okay, sp2 hybridization. If it goes to BF4 minus, BF4 minus, now check, H is equal to half of, boron 13th group. So total number of valence electrons 3 plus total number of monovalent atoms 4. Okay, now total positive charge 0, total negative charge 1. Total negative charge, half of, look here, half of V plus M minus C plus A. Total positive charge is 0, total negative charge is 1. Okay, so 4 plus 3 is 7, 7 plus 1 is 8. So half of 8 is what? 4. 4 means what type of hybridization? sp3 hybridization. Students, look here. Okay, so here BF3 is sp2 hybridized, whereas BF4 minus is sp3 hybridized. Okay, sp2 hybridization means, trigonal planar geometry. sp2 hybridization means trigonal planar geometry. Okay, trigonal planar geometry. sp3 hybridization means tetrahedral geometry. tetrahedral geometry, isn't it? Trigonal planar geometry or tetrahedral geometry. So if BF3 gets converted to BF4 minus, then there is a change in hybridization. If there is a change in hybridization, there is a change in geometry. Okay, so I can say, so this conversion okay leads to the change in hybridization as well as the change in geometry, where this is sp2 hybridized, this is sp3 hybridized, okay, this is trigonal planar, whereas this is tetrahedral. You can also prove it with respect to D, H2O and H3O plus, okay, H2O to H3O plus, H2O to H3O plus. Just calculate the hybridization for this. H is equal to half of, okay, yes, central atom is oxygen. Oxygen belongs to 16 group. So total number of valence electrons is 6. Total number of monovalent atoms is 2. 6 plus 2 is 8. Half of 8 is 4. Hybridization, if you are getting the value to be equal to 4, 4 means sp3 hybridization, isn't it? sp3 hybridization. How about here? H is equal to half of, okay, the central atom is oxygen. Oxygen means 16th group. 16th group means 6 valence electrons. Total monovalent atoms 3. Well, okay, total positive charge 1. 6 plus 3 is 9. 9 minus 1 is 8. Half of 8 is 4. Again, Haidnock, you are getting the value to be equal to 4. 4 means sp3 hybridization. So I can say H2O is also sp3, H3O plus is also sp3. So if there is no change in hybridization, there will be no change in geometry. Okay, so here also there is no change in hybridization, there is no change in geometry. There is no change in hybridization, no change in geometry. Here also no change in hybridization, no change in geometry. But here there is change in hybridization and also there is change in geometry. Hence the correct answer is option C. Okay, I hope you understood. Yes. Okay, exactly correct. Exactly correct. Yes. Next question, students. Okay, 37th question. Okay, the increasing order of bond order. The increasing order of bond order of O2, O2 plus, O2 minus and O2 2 minus. Well, it is O2, okay, 2 minus. Here we have 2 negative charge. Okay, 2 negative charge. So one is, okay, the increasing order of bond order of O2, yes, O2 plus, O2 minus and O2 2 minus, O2 2 minus. We have to just check what is the increasing order of bond order. Bond order means molecular orbital theory. Molecular orbital theory means electronic configuration. So which electronic configuration are you going to use? We will use the electronic configuration for the elements with, or for the molecules or ions with more than 14 electrons, because oxygen means more than 14 electrons. 8 plus 8 16, 8 plus 8 16, 16 16, more than 14 electrons, 14 electrons. So we will use that electronic configuration. Yeah, okay, which electronic configuration? We have to use molecular orbital theory to calculate bond order, because the question is on bond order. Observe, we are solving the previous year question paper from 2016. Okay, yes. So bond order, so to calculate the bond order, we should first write the electronic configuration. Which electronic configuration? Electronic configuration where the electrons are more than 14, is it? Okay, electrons are more than 14. And what is that electronic configuration? I think by now you are well versed in writing the electronic configuration. So what is the electronic configuration with more than 14 electrons? Yes, of course it's going to be sigma 1s, yes, sigma 2s, sorry, sigma 1s, sigma star 1s, yeah, okay, sigma 2s, sigma star 2s, okay, yes, sigma 2pz, sigma 2pz, and then pi 2px is equal to pi 2py, then pi star 2px is equal to what? Pi star 2py and then sigma star 2pz. Sigma star 2pz. Understood? Sigma star 2pz. Now let us take the different molecules. Okay, O2, O2 plus, O2 minus and O2, 2 minus. Now first one, I am going to take O2, O2. So total number of electrons here, 8 plus 8 is 16 electrons, isn't it? Total 16 electrons. So let us fill those 16 electrons here. Come on. Okay, 2, 4, 6, 8, 10, okay, 11, 12, 13, 14, 15, 16, isn't it? Okay, look here, they have unpaired electrons. There are 2 unpaired electrons. So here itself I'll tell you that there are 2 unpaired electrons. 2 unpaired electrons means it is of course paramagnetic. It has nothing to do with our question right now, but it is also very important. Please remember, O2 is paramagnetic. O2 is what? Paramagnetic. Understood? Now let us calculate the bond order. What is the formula to calculate the bond order? Yes, bond order is equal to half of Nb, yes, minus Na. Number of bonding electrons minus number of anti-bonding electrons. So let us use that formula. So bond order is equal to half of number of bonding electrons, 2, 4, 6, 8, 10. So 10, okay, remaining 6, isn't it? 10 minus 6 is 4, 4 by 2 is 2. So the bond order of O2 is 2. Okay, yes. Next, okay, next students, O2 plus. O2 plus. How many electrons are there? 8 plus 8, 16. 16 electrons, okay, but there is one positive charge. Okay, if there is positive charge, you have to subtract that positive charge with the total number of electrons. So 16 minus 1 is 15 electrons altogether. Okay, so shall we fill those 15 electrons? Yes, 2, 4, 6, 8, 10, 11, 12, 13, 14, 15. That's it. Okay, yes. So here also there is one unpaired electron. Okay, this also has one unpaired electron, hence it is also paramagnetic in nature. Paramagnetic in nature. Understood? Okay, so come on, calculate the bond order. Bond order is equal to half of, yes, okay, total bonding electrons, 2, 4, 6, 8, 10 minus number of anti-bonding electrons remaining is 5. So 10 minus 5 is 5, half of 5 is 2.5. So the bond order of, okay, O2 plus is 2.5 exactly. Next, O2 minus. O2 minus. So how many number of electrons here? 8 2s are 16, but there is one negative charge. If there is negative charge, then you have to add that charge with the total number of electrons. So it is going to be 17 electrons. 17 electrons. So let us fill those 17 electrons in this electronic configuration. Come on, 2, 4, 6, 8, 10, okay, 11, 12, 13, 14, 15, 16 and 17. 16 and 17. Okay, again there is one unpaired electron. One unpaired electron. That means this is also, okay, yes, what is it? Paramagnetic. This is also paramagnetic, exactly. This is also paramagnetic in nature. Now calculate the bond order. Bond order is equal to half of number of bonding electrons, 2, 4, 6, 8, 10. So 10, remaining is 7. So 10 minus 7 is 3. Half of 3 is 1.5. Okay, half of 3 is 1.5. 1.5. Okay, now last one. What is that last one? Okay, yes, O2 2 minus. Now count the number of valence electrons. Yes, total, 8 plus 8 is 16, but there is 2 negative charge. If there is 2 negative charge, you have to add that charge. If there is negative charge, add that charge. So 16 plus 2 is total 18 electrons. 18 electrons. So fill those 18 electrons here. 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Yeah, okay, yes. Is there any unpaired electrons here? No unpaired electrons. That means O2 2 minus is diamagnetic. Yes, O2 2 minus is diamagnetic. Exactly. It is diamagnetic in nature. That's correct. So can we calculate the bond order? Yes, bond order is equal to half of number of bonding electrons is how much? 2, 4, 6, 8, 10. So 10 minus remaining is 8. So 10 minus 8 is 4. Sorry, 10 minus 8 is 2. Half of 2 is 1. So the bond order for this species is 1. Okay. So what is the question? We have to arrange them in the increasing order of bond order. Increasing order of bond order. So let us write it here. You have to arrange them in the increasing order of bond order. So we have O2, okay, O2 plus, okay, O2 minus and O2 2 minus. Okay, what is the bond order of O2? This is 2. Bond order of O2 plus is 2.5. O2 minus is 1.5 and O2 2 minus is 1. Remember, all these three are paramagnetic, and only this is diamagnetic. Okay, diamagnetic. So can you please arrange them in the increasing order of bond order? So which one has least? O2 2 minus is least. Then comes what? Okay, O2 minus, then comes, okay, O2, and then comes what? O2 plus. So this is the increasing order, isn't it? Increasing order of bond order. So what is the correct answer? So O2 2 minus, O2 minus, O2 and O2 plus. Hence the correct answer is option D. Option D. Okay, simple? Yes, that's great. Okay. I am going slow because I want you to understand, but you can go faster. Okay, you don't have to take so much of time to solve one problem. Okay, I am going slow because I want you to answer every single thing that is involved in it. Okay, yes. Yes, students, next question. Okay, so the main axis, okay, the question says the main axis of diatomic molecule is Z. The orbitals px and py overlap to form pi molecular orbital, sigma molecular orbital, delta molecular orbitals, or no bonds is formed. No bond is formed. If the main axis of diatomic molecule is Z, if the main axis is Z, the orbitals px and py overlap to form pi molecular orbital, sigma molecular orbital, delta molecular orbital, or no bond is formed. See, students, understand. Okay, see, using molecular orbital theory, we wrote an electronic configuration, isn't it? We wrote it for the species with less than 14 electrons and also for the species with more than 14 electrons, isn't it? Okay, what will be the electronic configuration for the species with less than 14 electrons? Okay, or more, you take up any electronic configuration here. Let us say I'll take the electronic configuration with more than 14 electrons. See, okay, what is the way we used to write it? The way we used to write it as sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. There is no problem with, okay, 1s and 2s. If we go for 2p, for 2p we have three different orbitals. 2p subshell has three different orbitals, isn't it? Which are those three different orbitals? It is 2px, 2py and 2pz. So out of these three orbitals, you have to choose one as the main orbital. Okay, if you choose one as the main orbital, the other two orbitals will form pi bonds. Okay, and the main orbital is going to form the sigma bond. Okay, if you now out of the 3 orbitals, if you choose, it is arbitrary, you can choose anything. If you choose any one of the orbital as main orbital, the main orbital is going to form sigma bond, the other orbitals are going to form pi bond. Say if I choose, okay, 2pz as the main orbital, well, this main orbital will form what bond? Sigma bond, whereas the remaining 2 orbitals will form what type of bond? Pi bond. That is what we used to write. Okay, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and then we used to write what? Sigma 2pz. Okay, followed by what? Pi 2px. Look at here, 2px. If I choose this as the main orbital, these 2 orbitals will form what? Pi bond. Pi 2px, pi 2py, correct? Okay, and then pi star 2px, okay, pi star 2px, pi star 2py, pi star 2py, and lastly sigma star 2pz, sigma star 2pz. Are you getting my point? So if you choose any one of them as the main orbital, that main orbital will form sigma bond, and the remaining 2 orbitals will form what? Pi bond. On the same lines, if I, okay, instead of 2pz, if I choose 2py as the main orbital, if I choose 2py as the main orbital, if I choose these main orbital, then okay, 2py will form sigma bond, whereas these and this will form what? Pi bond. So the electronic configuration is going to be sigma 2py, sigma star, okay, sigma star 2py, pi 2px, pi 2pz, pi star 2px, and pi star 2pz. This is how it is going to be. Or else if I choose 2px as the main orbital, 2px as the main orbital, yes, okay, 2px as the main orbital, okay, then this main orbital is going to form sigma bond, whereas the other 2 orbitals is going to form what? Pi bond. Now the electronic configuration is going to be sigma 2px, okay, pi 2py, pi 2pz, pi star 2py, okay, and pi star 2pz, okay, and sigma star 2pz. Sigma star 2pz. This is what, sorry, sigma star 2px. This is what the electronic configuration is going to be. So if you choose one as the main orbital, that main orbital will form sigma bond, and the other 2 orbitals will form what? Pi bond. Now the question is, the main axis of diatomic molecule is Z. That means they have chosen what? They have chosen 2pz as the main axis. 2pz as the main axis. If they have chosen this as the main axis, that means this is going to form what? Sigma bond, and these 2 is going to form pi bond. Therefore the electronic configuration is going to be sigma 2pz, okay, pi 2px, pi 2py, pi star 2px, pi star 2py, and sigma star 2pz. So now can you answer this question? Again, we have got 2 questions from 2016. So it has become mandatory, students. Okay, so from every year they are giving 2 questions from this chapter. Okay, so 2 questions, even in NEET, even in JEE mains, at least you can expect 2 questions from this chapter. NEET 2 means 8 questions. 2 means how many questions? I mean, how many marks? 8 marks. 2 4s are 8 marks. JEE means 2 4s are 8 marks. Please be careful. Okay, emphasize more on this chapter. Okay, yes. So what is the question? So the question is, the main axis of diatomic molecule is Z. The orbitals px and py overlap to form. So if the main axis Z, then px and py will overlap to form. Px and py will overlap to form what? Pi molecular orbital. Okay, pi molecular orbital. Okay, it will overlap to form pi molecular orbital. Okay, any doubts? Okay, yes, students. Okay, next question. Okay, which of the following structure of a molecule is expected to have 3 bond pairs and 1 lone pair of electrons? Which of the following structure of a molecule is expected to have 3 bond pairs and 1 lone pair of electrons? 3 bond pairs and 1 lone pair of electrons. So that means, okay, the structure has both, okay, look at here, the structure is given, the given structure has 3 bond pairs and 1 lone pair, isn't it? 1 lone pair. Okay, the structure has both bond pairs and lone pairs. Okay, the structure has both bond pairs and lone pairs. If the structure has both bond pairs and lone pairs, what do you call that structure as? Irregular geometry, isn't it? Irregular geometry. Is that correct? If the structure has both bond pairs and lone pairs, we will call it as irregular geometry. For irregular geometry, I have given a table. Do you remember that? I have made you to write a table. What is that? Table consisting of bond pairs and lone pairs and the shape. Bond pairs, lone pairs and the shape. Do you remember I have asked you to remember a word called as what? Beats. B, E, A, T, S. Okay, replace this EA by what? P. Okay, yeah. That is why I am asking you to watch each and every video of mine seriously. Okay, yes. See, because it has been asked in Karnataka CET 2017. So, okay, so bond pair, lone pair and shape. Look at here. Okay, how did I write? 21, yes, 22, yes, 31, 32, 41, 42, 51, 52. Didn't I write this? Okay, yes. 2 bond pair, 1 lone pair. What is the shape? B means what? Bent. Bent. Is that correct? Okay, next. 2 bond pairs, 2 lone pairs. Again, B. Bent. Bent. Again is the word what? Bent. Okay, 2 bond pair, 1 lone pair, bent. 2 bond pair, 2 lone pair. Again, it is bent. 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 3 bond pair, 1 lone pair. Next word is P. P means pyramidal. 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 Okay. 3 bond pairs, 1 lone pair means pyramidal geometry. Okay. Are you getting it? Next. 3 bond pair, 2 lone pair. Next. T. T means T shape. T shape. Okay. Correct. Beat, bent, P for pyramidal and T for T shape. Next, 4 bond pair, 1 lone pair. Okay, next word, yes, seesaw. Seesaw. Next, okay, 4 bond pair, 2 lone pair. Again, yes, okay, square planar. Square planar. Square planar. Okay, 5 bond pair, 1 lone pair. Again, yes, square pyramidal. Square pyramidal. Pyramidal. And lastly, 5 bond pair, 2 lone pair. This is called as linear. Okay, see, look at here. B, B, P, P. Okay, B, B, P, T, S, S and S. Beats. Use the word beats. Bent, pyramidal, T shape, seesaw, square planar, square pyramidal. Okay, so the question says, which of the following structure of a molecule is expected to have 3 bond pairs and 1 lone pair? Look here. Okay, 3 bond pairs and 1 lone pair. Therefore, the structure is going to be what? Pyramidal. Okay, the structure is going to be what? Pyramidal. Understood? Very simple. Pyramidal. Okay, 3 bond pair and 1 lone pair means pyramidal structure. Simple, students. Please remember this table. I keep telling you, remember, memorize the things, memorize the concepts again and again. Okay, so how do you remember? 21, 22, 31, 32, 41, 42, 51, 52. Use the word beats. Replace EA by P. B, bent, P, pyramidal, T shape, S, seesaw, square planar, square pyramidal, and last one, linear. Okay, so which of the following structure of a molecule is expected to have 3 bond pairs and 1 lone pair? So it is pyramidal geometry. Pyramidal geometry. Okay, yes. Yes. Next question. Okay. Yes. Which of the following is the correct electron dot structure? Electron dot structure means Lewis dot structure of N2O molecule. Yes. Which of the following is the correct electron dot structure of N2O molecule? Students, when I was talking about the theoretical aspects of this chapter, I told you that I'm going to teach you the Lewis dot structure for more number of molecules. So okay, so here comes the chance wherein I can teach you the Lewis dot structure, okay, using this molecule. Okay, again look here, previous question is also from 2017, this question is also from 2017, but that means to say minimum of 2 questions for in each each year. 2015 we can just check. Okay, yeah, yes, 2014 2 questions, 2015 2 questions, 2016 2 questions, 2017 2 questions. Okay, isn't it? Okay, yes, yeah. So now, so here I have got a chance to teach you how to draw the Lewis dot structure. Okay, okay. So I'll use this molecule. Which molecule? N2O molecule. Yes. So let me write the Lewis dot structure for N2O molecule. Okay. Yes. For N2O molecule. Okay. So students, here nitrogen is less electronegative than oxygen. Then consider nitrogen as the central atom. Okay, nitrogen is the central atom. Central atom. Okay, yes. Okay, because the nitrogen is less electronegative than oxygen. There are 2 nitrogen atoms. Use one of the nitrogen as the central atom. Okay, yes. Use one of the nitrogen as central atom. The other nitrogen and oxygen is going to be the terminal atoms. Okay, let us go with the steps, students. Let us go with the steps. First, count the total number of valence electrons in all the atoms. Okay, total number of valence electrons. There are 2 nitrogen. Nitrogen belongs to 15th group. I have kept telling you again and again. Nitrogen belongs to 15th group. 15th group means 5 valence electrons. So there are 2 nitrogen. 5 2s are 10 valence electrons. Okay, 10 valence electron. Okay, oxygen belongs to, okay, 16th group. So 16th group means how many valence electrons? 6 valence electrons. Okay, so if there is positive charge, you have to subtract that charge with the total number of valence electrons. If there is negative charge, you have to add that charge to the total number of valence electrons. Remember that point. So 10 plus 6 is, okay, total 16 valence electrons. Okay, total 16 valence electrons. Is that correct? Okay. Now, okay, I told you consider one nitrogen as the central atom, the other nitrogen and the oxygen as the terminal atom. So write one nitrogen at the center, okay, one other nitrogen and oxygen at equal distance. That means, okay, like this. Clear? Next, join the central atom and the terminal atoms by a single bond. By a single bond. Okay, join the central atom and the terminal atom by a single bond. Okay, now give this, okay, come now, distribute these 16 valence electrons among the 3 central as well as terminal atoms. Okay, distribute the 16 valence electrons with the terminal, central and the terminal atoms. Look at here, how I'm going to distribute. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14. Okay, I'll just take one more here, 15 16. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Just check. Okay, we have distributed the 16 valence electrons. Fine. Now just check whether the octet structure is complete for all the atoms. Okay, look here, 1 2 3 4 5 6. No, octet structure is not completed. 1 2 3 4 5 6. Octet structure is not completed. Okay, 1 2 3 4 5 6 7 8. Only for oxygen octet structure is complete. Only for oxygen octet structure is complete, not for nitrogen and for this nitrogen, isn't it? Okay, so for this nitrogen, if the octet structure is not complete, for the central atom, if the octet structure is not complete, okay, so make use of one, okay, lone pair of electrons and draw a double bond. Draw a double bond. Okay, is that correct? Any doubts? Okay, so now just check whether the octet structure is complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sorry, 1, 2, 3, 4, 5, 6. No. For this 1, 2, 3, 4, 5, 6, 7, 8. For this nitrogen, yes, completed. How about for this nitrogen? Oxygen 1, 2, 3, 4, 5, 6, 7, 8. Yeah, for this oxygen it is also completed. Whereas for this nitrogen, the octet structure is not complete. Okay, wait a minute. See, instead of drawing the lone pair of electrons from this, I'll draw the lone pair of electrons from this. Okay, now just check whether the octet structure is complete. Yes. Okay. Well, 1, 2, 3, 4, 5, 6. No. How about for this? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, octet structure is complete. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Octet structure is complete. But for this nitrogen, the octet structure is still not complete. So if the octet structure of this nitrogen is not yet complete, again draw this lone pair of electrons and make it as a triple bond. Okay, use the lone pair of electrons and make it as what? Triple bond. Triple bond. So if nitrogen has 4 valencies, we know it will going to get what? Positive charge. It will get positive charge. If nitrogen has 4 valencies, it will get what? Positive charge. Now just check whether the, okay, so octet structure is complete for all of this. 1, 2, 3, 4, 5, 6, 7, 8. Octet structure is complete. 1, 2, 3, 4, 5, 6, 7, 8. Here also octet structure is complete. Okay, next for this 1, 2, 3, 4, 5, 6, 7, 8. Yeah, octet structure is complete. So for all of them, the octet structure is complete. Okay, yes. Now check the formal charge on all these, okay, atoms. Okay, let me check the formal charge on the first nitrogen, okay, second nitrogen and oxygen. Let us check the formal charge. What is the formula to calculate the formal charge? Formal charge is equal to, do you know, V minus L minus half of S. Okay, V means total number of valence electrons. Okay, yeah, total number of valence electrons on that atom. L means, okay, number of lone pair of electrons. Okay, S means what? Total number of shared pair of electrons. Okay, so let us calculate the formal charge on the first nitrogen. Okay, the formal charge on the first nitrogen. So nitrogen 15th group. 15th group means 5 valence electrons minus number of lone pair of electrons 2 minus half of number of shared pair of electrons 2, 4, 6. Well, okay, 5 minus 2 is 3. Half of 6 is 3. So 3 minus 3 is 0. So what is the charge on this, formal charge on this nitrogen? 0. The formal charge on this nitrogen is 0. Okay, that's exactly correct. Next, let us calculate the formal charge on this nitrogen, second nitrogen. Again, nitrogen belongs to 15th group. So total number of valence electrons is 5. Okay, yes. Number of lone pair of electrons is 0 minus half of, okay, shared pair of electrons. Okay, come on, check. 2, 4, 6, 8. Half of 8. Okay, yes. So 2 1s are 2 4s are 5 minus 4 is plus 1. So the formal charge on this oxygen is plus 1. Okay, the formal charge on this nitrogen is plus 1. On the same lines, calculate the formal charge on oxygen. Yeah, oxygen 16 group, 6 valence electrons minus total number of lone pair of electrons 2, 4, 6 minus half of shared pair of electrons is, okay, 1, 2. Okay, 6 minus 6 is 0. Okay, yes, 0 minus 1 is minus 1. The formal charge on this oxygen is minus 1. Plus 1, minus 1. Therefore, this is the exact formal charge. Okay, so this is the exact Lewis dot structure of N2O molecule. Where do you find this? Yeah, we have it here. Look here. Yeah, it is given. If it is not visible, N triple bond N plus, okay, O. 6 lone pair of electrons and 1 negative charge. Do we have the same? Okay, yes, positive charge and 1 negative charge. Hence the correct Lewis dot structure for this molecule is, okay, yes, it is option B. Option B. Okay. Hope you have understood, students. Which of the following is the correct electron dart structure for N2O molecule? Yes, of course, it is option A. Okay. Simple. Yes. Next question, students. Next question. Just a minute. Okay. With your permission, let me have a sip of water. Yeah. Next question. Okay. The correct order of, okay, the correct order in which OO bond length increases in the following. Okay. The correct order in which OO bond length increases in the following. Okay. You should calculate the correct order in which, okay, the OO bond length, oxygen bond length increases in the following. So they have given three molecules. One is hydrogen peroxide, okay, and then O2 and then O3. Okay, this is All India Pre-Medical Test 2005. Okay, we have hydrogen peroxide, O2 and ozone. See, hydrogen peroxide. Okay, I hope you know the structure of hydrogen peroxide. We have studied this in 11th standard itself. That is in, okay, what? Hydrogen chapter. What is the structure of hydrogen peroxide? It is basically open book like structure. Okay, the structure of hydrogen peroxide is open book like structure, isn't it? And here, okay, you can observe that between oxygen we have single bond. Single bond means bond order is how much? 1. Okay, for single bond the bond order is 1. It's purely a single bond. So single bond means the bond order is 1. Now if you take O2 molecule, O2, how do you represent O2? Like this, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is O2. And between two O2 molecules, that is purely double bond. Okay. For double bond, the bond order is 2. Okay. For double bond, the bond order is 2, isn't it? Whereas for ozone, what is the structure of ozone? O3. Yes, this is how we write ozone, isn't it? 1, 2, 3, 4. Okay. Yes. 1, 2, 3, 4. Okay. 5, 6. So this is the structure of ozone. Look at here, between two oxygen atoms there is double bond, and between these two oxygen atoms there is single bond. Therefore, do you say that the bond order of this oxygen is, these two oxygen is 2 and the bond order of these two oxygen is 1? No. Actually, this molecule is resonance stabilized. The molecule is resonance stabilized. Okay. How is it resonance stabilized? This negative charge, this lone pair of electrons will be shifted here, and this pi electrons will be shifted to this oxygen. Therefore, the next resonating structure is going to be like this. O, O, O. Okay. So since this lone pair of electrons is shifted here, we will get double bond here. This remains as such. And since this pi electrons are shifted on this oxygen, oxygen will get one extra lone pair of electrons. Now compare these two resonating structures. Compare these two resonating structures. In one resonating structure, okay, there is double bond on this between these two oxygen, and on the other resonating structure there is single bond between these two oxygen atoms. Okay, in one resonating structure there is single bond between these two oxygen atoms. In the next resonating structure there is double bond between these two oxygen atoms. Therefore, single double single, single double. Therefore, can I say that it is partial double? Correct? Partial double. Okay. Partial double bond. Okay. For partial double bond, what is the bond order? Bond order is 1.5. The bond order is 1.5. Correct? Okay. For partial double bond character, the bond order is 1.5. Understood? Okay. So you can observe here, the bond order for hydrogen peroxide is 1. The bond order for O2 molecule is 2. Whereas the bond order for ozone molecule is 1.5. 1.5. Got it? Now, what is the question? The correct order in which the OO bond length increases. He is talking about bond length. Okay. bond length. How many times I have told you that bond order is inversely proportional to bond length? Okay, bond order is inversely proportional to bond length. More the bond length, more the bond order, lesser will be the bond length. Am I correct? If the bond order is more, less will be the bond length. So you have to arrange them in the increasing order of bond length. Increasing order of bond length means increasing order of bond length means decreasing order of bond order, isn't it? Decreasing order of bond order, correct? Okay, bond order, because bond order is inversely proportional to bond length. So what is the correct answer? Increasing means decreasing order. Okay, so this has bond order equal to 2. Okay, so first comes O2 and then comes O3 and then comes what? H2O2. So bond order for this is 2, for this is 1.5, for this is 1. So you know, decreasing order of bond order means increasing order of bond length, because bond order is inversely proportional to bond length. Okay, so if the bond order decreases, bond length increases. So therefore this is the correct bond. Okay, this is the correct order of bond length. Yes, what is the correct answer then? Yes. Okay, oh sorry, we have left out. Here it is H2O2. Okay, yes, the answer is option C. Option C. Okay, so students, I'll continue in the next class. Thank you.